So this is the third part to a question. You can see the link below for the first two parts of the question. So we are asked to show that if A, B, C, D are points on the sphere centered at O, and if AC meets BD at M, where lambda prime BM equals to mu prime MD, then and with lambda prime plus mu prime equals to 1, then lambda mu A minus C mod square equals to lambda prime mu prime B minus D mod square. And okay, it's interpreted this way because, so I'm just rearranging, so we know that the ratio of BM to MD is mu prime to lambda prime. So BM to MD is mu prime to lambda prime. So in the earlier part, which you can also see the video in the earlier link, we have proved that in the link below, we have proved that mod M square equals to lambda mod A square plus mu mod C square minus lambda mu mod D A minus C mod square is true if under this condition, if lambda plus mu equals to 1 and AM over MC equals to mu over lambda. So this is very similar to the question we have here. So given this, which is what we have proved earlier. So you realize that this is true when the question in the part 1 shows that this is true, this thing is true, this equation is true if these conditions are satisfied. If M is a midpoint on AC, if this is satisfied, and lambda plus mu equals to 1. So we can say the similar things for BD. Just now this is for AC and AM and MC. We can say the same for our BD, because M in this case, the M of AC is also the M of BD, is also a point on BD, and lambda prime behaves like, it's just like my lambda prime BM is just like my lambda AM, and mu prime MD is just my mu MC. So there are these parallels, and then lambda prime plus mu prime is equals to 1, just like my lambda plus mu equals to 1. So we can say the same thing, we can apply this formula for BD, and so I replace A with B and C with D, and A with B and C with D. So then the lambda and mu I replace with lambda prime and mu prime respectively. So I get this equation. So we are asked to prove this, and becomes easy because since this is equals to mod M square and this is equals to mod M square, so that means lambda mod A square plus, I'm taking it from here, lambda plus mu mod C square here minus lambda mu mod A minus C square here is equals to my lambda prime mod B square plus mu prime mod D square, I'm taking from here, minus lambda prime mu prime mod B minus D square here. So because they are equal, both are mod M square. So now since the points are all on the sphere, that means an origin is at the center of the sphere. You see, from the origin to any part, any point on the surface of the sphere, the distance is the same. That's why it's a sphere. It's a round, it's like a ball. So any point on the surface of the ball to the center of the ball has equal distance. Therefore, mod A is just the distance from the center to the surface, and mod B is the center to the surface. So they should all be equal. That's the reason that actually I can replace all the mod C square with mod A square also. And this one mod B square I can also replace with mod A square since they are equal length. And mod D square also can be replaced with mod A square. If I do that, then it means that all this can be simplified. So I can say that, okay, this is actually, this one becomes lambda, this is, since I change this to mod A square also, so it's just become lambda plus mu, I factorize out mod A square, you understand? And because let's say mod C squared, mod C equals to mod D, so mod C squared will equals to mod A squared. So I'm factorize out mod A squared. So same thing for here. I can also change mod B and mod D to mod A. So lambda plus mu is further lambda plus mu from the earlier part, we know that is equals to 1. So this is equals to 1, so the whole thing just reduced to a mod A squared. And same thing for here. Lambda prime plus mu prime is also given to be equals to 1. So this part also reduced to just mod A squared. Even I replace mod B and mod D with mod A also. So this basically, this is mod A square, this part is mod A square, and this part is mod A square, so they just cancel off. And then we arrive at the proof. We just multiply a negative on both sides of the equation, and we arrive at the proof, because we are just left with this equals to this, right? And a bit messy, but let's if you want, we can recap, like just write the time, just write it properly. So looking at here, so lambda mod A square plus mu, instead of mod C square, I'm going to immediately change it to mod A square minus lambda mu mod A minus C square equals to, if you already gotten it, you can move on. There's nothing more about for this question. So I'm just going to rewrite it nicely. So lambda prime mod B square, I'm going to change it to mod A square, since mod B and mod A are equal. So plus mu prime mod A square minus lambda prime mu prime mod B minus D square, right? All these need a tutor, because this tutor stand for vectors, differentiates from scalars like lambda and mu. So since then the left hand side becomes lambda plus mu mod A square, right, minus lambda mu mod A minus C square equals to lambda prime plus mu prime mod A square minus lambda prime mu prime mod B minus D square. And this is 1, this is 1, and this is 1, based on here and here, right? So I have, because both are 1 and both are mod A square, so I cancel them away, left with them, because this is plus plus, I just multiply minus on both sides, I get what they want me to prove. So that's it for this 3-part question.